this will be K1 K1 K2. Here it will be, and after this you know that K1 K2 they are in series, K1 K3 they are in series, and we can proceed here. So why only we should do like this? So other student, what happened? Other student will proceed in the other way. I'll show that one. So now among them, who is right, who is wrong, we have to justify. So this will be the x sine y. K1, so this will be how much area of cross sectional plates will become a by 2, a by 2, a by 2, a by 2. So C12 parallel to C13. Again C12 we have to calculate. First we'll calculate C12. C1 by C12 should be equal to, this will be the separation between the plates, d by 2 K1 epsilon naught a by 2, d by 2 K2 epsilon naught a by 2. I think this by 2 will get cancelled out. So 1 by f naught 1 by K1 plus 1 by K2. Altogether, what is C12? I can write f naught a d K1 K2 by K1 plus K2. Straight away I can write it. Now C13 also, the similar way, d by 2 solving this will end up K1 K3 by K1 plus K2. Now these two are parallel. These two are parallel. The effective capacitance CXY should be equal to C12 plus C13. This was the answer given in the book. Why we should think like this only? What's wrong if I do either way? This is what I think that one. So what I do is I'll go by either way. What is that one? I'll second method.
C13 it should be K1 plus K3 in the denominator.
Which one?
C13 equal to epsilon naught A by K1 K3 by K1 plus K3.
K3 here 2 is there. Okay, I think symbols all here. This is okay now. See that I'm breaking up this capacitor in this way here. So now what I do is like I'm going to break up. I'll not break up K1. K1 is one capacitor that is in series with effective of K2, K3. So other student, what happen? You will just do like this, the same problem. This is y, this is x, this is 1, this is d by 2. Area of cross sectional plates is A. This is a by 2, and this is d by 2. This is K2, K3. So C23 first we'll find out. C23 should be equal to K2 epsilon naught a by 2 d by 2 plus K3 epsilon naught a by 2 d by 2. K2 plus K3 epsilon naught a by d. And what is C1 is K1 F naught A by D by 2. And how this effective will be? C2, 3. This will be in series. So therefore, Cxy is equal to 1 by C1 plus 1 by C2, 3. D by 2, K1 F naught A. This is D. K2 plus K3 F naught A. So this should be 1 by 2 K1 D by F naught A 2 by K1 K2 plus K3 F naught A by D 2K2 2K3 plus K1. I got different answer.
You wrote reverse, sir.
This K1 K2. I'll send it. Now how to, this is K1 K2 plus K3 by K1 2 times of
There it should be 1 by 2 K1, sir. You wrote 2 by K1 before step.
this one, 1 by 2 K1. What changes will come then?
2 K1 into K2 plus K3 by 2 K1 plus K2 plus K3.
2 K1. Oh, here 2 K1 will come here. Okay, check once. Two K1 plus K2 plus K 2 K1 plus K2 plus K3 2 K1 into. So this will become 2 K1 K2 and there's a final formula answer I'm writing. But if you check it, no, they are different. Then who is right, who is wrong? We have one.
Second one, sir.
Second one,
Second one.
yes, sir.
Yes, sir.
Any reason? Why not?
Charges
Why not the
flowing through
first one?
slab will be different.
Then charges through the slab should be different. There's a first one you see once. There's a first thing what we have. There's the first situation overall. And next, yellow, K2 is yellow. No? Just only the way we are, the capacitors will be there like that only. No? So only thing, our simplification is something we are thinking in different ways here. So definitely what happened, one thinking is connect both there's like you connect one like an instrument which will measure capacitance. So will the instruments should read same value or different value? Different value, because one you are having one value, other value, and both instruments are exact. There's no problem with the instrument. If the both the methods, if they get same answer, okay, then we would have concluded, we would have said, okay, manage either way, carry on in either way, no problem. But we're getting different answers. So definitely there is some idea must be involved. There should be some method is involved here in breaking up the slab. So like here, the equivalent here, what we did, we just divided this K1 into two parts, a part of K1 in series with K2, a part of K1 with K3. This is what we did first method. Second part, we didn't do like that. K1 is one capacitor. Then we just broke that capacitor into D by 2, D by 2. So one part of the D by 2 will have only K1. The other part will have combination of K2, K3. Practically, if I measure, see, I do one thing, I'll measure practically. So at least one is the practical, the instrument will read any one value, either the first or second one. So we have to give reason. Where we have to, whose help we have to take it. So definitely what happened, the ideas, little bit what we know, with that we have to go for it. So already, do we have enough information? Yes, something we manage, no? To support this, we do have a question in SC Verma. I don't remember. In group, I'll mention it. You just think once that question. So that really best question where which will help you to load. So I'll find out the induced charge here on the slab. Okay, got this. And we know that charge on this plate and this plate, because I'll connect a cell, no? And the charge of a cell should be converted. When you connect a cell, the cell will push a charge. So the Q charge will come. It will induce charge. Then electrostatic induction will occur, and here the same what charge entered the capacitor, that much should leave here. So what will happen to charge distribution? What do you say about charge distribution here? Will in this upper part and lower part will be same? The answer is no. So here actually this slab, no, here I shown a gap, but practical open, I'll fully fill up, no. This particular slab will be in contact with the plate. So what is the charge here? The resultant is what you have to take it. There's a charge minus Q and this induced charge. The resultant of that will be there. When I go and check it, no, this charge will be different. Definitely here, this charge should be different. So therefore, when a charge comes here, what happens? It will split up. It will not be same, it will split up. And what charge will split up? That will pass through K1, K2 here. What charge will split up will pass through K1, K3 here. Or if you go back to electromagnetic waves, there we get a displacement current idea. Displacement current. Now what we are discussing is the conventional current. We do have one more current called as displacement current. With that, what happened there? Exactly what happened? A displacement current here and here will be different. How do we can say, so like I'll measure magnetic field. I'll measure magnetic field. So when I measure magnetic field nearby this and this, the superposition will occur. It'll be different here. So we do have one problem. Is there in EDO also? Tomorrow I'll discuss that one. So I can show that the charge here and here will be different because of this case. The charge will not be same on this plate at upper region and lower region. So what's happening to charge? The charge gets splitted up here. This one. So here what happened? You are assuming as if what happened? Charge Q. Okay, this particular thing. So same charge will be here. So when you go and check it here and here, it will be different. And definitely, so here and here will be different here. So here what happened? This way of measuring will be wrong. So here, what according to the concept, what you are saying here, same charge. But practically what happened, if I go and check it now, the charge at this region and this region will be different. On the conducting plate itself, I'm telling. Okay, so the charge induced here will be, it's also determined by the influence of K1, K2 will come, here K1, K3 will come. So therefore, it should be this one. This was asked in advance. Some books they're given this, some books they're given this. But actually you have to take help of the induced charge and the displacement current. Actually the idea is related from there. Okay, got this one? So the first method is correct. The second method wrong. I'll erase it. This is the correct. What we did, no? So this is correct. This I'll say that this is totally wrong. Wrong idea. Wrong answer. And still some books, again, they are dumping the wrong thing also. You have to be careful. Tomorrow we'll start with this one, numerical based on this idea only. Okay, thank you all of you. Any doubt you can clarify? Any small doubt is there?
Sir,
Ah,
in the iron slab kept between the capacitors.
yeah.